Let me start with a simple question. How do the foods we eat every day stay safe, fresh, and consistent? For many years, food processing focused on three main things: heat, mass, and fluid flow. But today, modern food systems are changing. Now, food factories are not only controlled by machines, they are also controlled by data and information. This means factories can monitor their processes, detect problems early, and even adjust operations automatically. Food engineering is no longer just about producing food. It is about creating smart systems that improve safety, efficiency, and sustainability. One of the most common food preservation methods is thermal processing, such as canning. In traditional systems, food is heated to very high temperatures, around 121 degrees Celsius, and held for a certain period of time. This process kills harmful microorganisms and keeps food safe. However, because engineers cannot always measure the exact conditions inside every container during processing, manufacturers often over-process the food to ensure safety. While this protects consumers, it can also lead to nutrient loss, texture damage, and extra energy consumption. Today, modern systems use real-time sensors and digital monitoring to control temperature more accurately. This helps maintain food safety while preserving more nutrients and saving energy. In the past, food quality testing happened after production. For example, milk samples were sent to laboratories to measure fat or protein content. But modern food factories now use inline sensors that monitor food continuously during production. One technology used is near-infrared spectroscopy. That method uses light to analyze the composition of food without damaging it. By measuring how light interacts with the product, the system can instantly determine levels of fat, protein, and moisture. This allows factories to detect problems immediately and adjust the process in real time. The result is better quality control and less waste. Traditionally, food inspection relied heavily on human workers. Humans are very good at recognizing patterns, but people can become tired and make mistakes. Today, many food factories use robotics and machine vision systems. These systems use cameras, artificial intelligence, and advanced algorithms to inspect food products. In some meat processing facilities, AI-guided cutting systems analyze each product's shape and determine the most efficient way to cut it. Even a 1% improvement in yield can save millions when processing large amounts of food every day. Another important innovation is predictive maintenance using artificial intelligence. In traditional factories, machines are repaired only after they break down. This leads to unexpected downtime and production losses. Modern systems use sensors to monitor vibration, temperature, and motor performance. Artificial intelligence analyzes this data and detects unusual patterns. This allows engineers to identify potential problems before equipment fails. As a result, maintenance can be scheduled early, reducing costs and preventing disruptions. Modern food engineering is also exploring nanotechnology. Nanoemulsions contain extremely small droplets measured in nanometers. Because these droplets are so tiny, they provide better stability and improved absorption of nutrients. Scientists can also use nanotechnology to encapsulate vitamins, antioxidants, and flavors. These nutrients can be protected during processing and released more effectively in the body. This opens the possibility of designing foods that deliver greater nutritional benefits. Packaging has also evolved significantly. In the past, packaging mainly served as a passive barrier that prevented oxygen or moisture from entering. Modern packaging systems are more advanced. Some packaging materials contain antimicrobial agents that slow the growth of bacteria. Others include oxygen scavengers that remove oxygen from inside the package. Some systems can even monitor food quality or track products digitally through the supply chain. These technologies help extend shelf life and reduce food waste. Another emerging innovation is the use of digital twins. A digital twin is a virtual model of a real factory or process. Engineers use these simulations to study mixing, heat transfer, and airflow before building actual equipment. This allows companies to test improvements safely in a virtual environment. As a result, innovation becomes faster, cheaper, and more efficient. Food processing has come a long way. From traditional preservation methods like salt and fire to modern systems powered by sensors, data, and artificial intelligence. Today's food engineers must combine knowledge from many fields, including engineering, microbiology, automation, and data science. Modern food factories are becoming intelligent systems that continuously monitor, learn, and improve. And the innovations we develop today will shape the future of global food production. Be a food Samaritan today. Like, follow, and subscribe, because every safe meal starts with you.